So this is still about systems, and this is kind of still elimination. We're going to use elimination, but notice, like with these two equations in the system, if I were just to add these together, nothing's going to drop out. This will give me 6x. This will give me negative 2y. My goal in elimination is to actually eliminate one of the two variables. So I'm just going to dream a little bit. Like I noticed this is a negative 3y. If this was a positive 3y, then when I add them together, they would cancel. So what I'm going to do is I'm going to keep the top equation just as it is. Whoops, just as it is. That's better. And then this second equation, I'm going to multiply it by 3. I'm going to multiply both sides by 3. And notice if I do that, left equals right. I haven't changed the relationship between an x and y. But if I multiply this whole thing by 3, what I end up with then is 12y, or 12x plus 3y equals 30. And notice when I did that, now when I add the two equations together, the y's are going to drop out. And I could have made it so the x's drop out. I could have multiplied this one by negative 2 to make that a 4x and a negative 4x. I just chose the y's. So now it's set for elimination. So now I'm going to add the equations together. Add the left sides, add the right sides. 2x plus 12x, that's a 14x. That's a 0, which is what I wanted to happen. That was by design. And this is, what, 42. Great, so keep going from there. Divide both sides by 14, and I get a 3. So I know x is 3. Knowing x is 3 is great. I need to know what y is. So I can take that 3 value and plug it back into either one of my equations. So I'll plug it into this top one. 2 times x is 3. Minus 3y equals 12. 6 minus 3y equals 12. Subtract 6 from both sides. Negative 3y equals 6. Divide by negative 3. Looks like y equals negative 2. I can write my answer this way, or I can write it as the ordered pair x, y.